Hello everyone. Today in this video we'll be discussing the last topic of chapter 2, that is patterns in whole numbers. Now although this topic is not that much of importance, but still since it is given in your textbook, we'll be discussing it. We'll be discussing the different patterns that are being followed in whole numbers. Now this pattern can be a symbolic representation of the elementary shapes, or there can be a pattern of simplification. So we'll be discussing that here. So let us begin. Now here it is directly given to you, but before that let me explain you what is this thing. In here what we have done is we have arranged the numbers in the elementary shapes, or you can say in the symbolic representation of dots. Through dots we will represent the numbers, as well as the numbers can be arranged in such a way that it represents a shape. So let us see the first example. You can see the number 2 can be denoted by a 2 dots. You can see here this dot and this dot. Don't consider this, just focus on these 2 dots. Now if we see these 2 dots, does it represent any shape, elementary shape? Yes, it denotes a line. If we connect this, although it is not connected here, but if we connect it imaginarily, by imagining ourselves, it represents a line. So this number 2 can be denoted in this manner. It can be arranged as a line. Similarly, the number 3 can be arranged as a line. Almost all the numbers, you can say, other than 0, which is also a whole number, other than 0, all the numbers can be represented through dots, and these dots can represent a line. All the numbers, all the whole numbers. Although the line will increase, the length will increase, but all the numbers can be denoted except 0. 0 cannot be represented. So now next is the number 6. 1, 2, 3, 4, 5, 6. Now if we connect all of them, it represents a rectangle. So you can see here, note there are 2 rows. This is the first row, this is the second row, and these are the horizontal ones are rows and the vertical ones are columns. There are 3 columns. Clear? This number 6 can be represented as a rectangle, which is also an elementary shape. Now moving on, some numbers like 4 and 9 can also be arranged as squares. You can see 4 and 9. Clear? This 4 can be represented in this way. So it represents a square. Now the number 3 again can be represented. Earlier we have seen the number 3 can be represented as a line. Now here it can also be represented as a triangle. You can see if we connect these all points or dots, we can get a triangle. Similarly, this number 6, we have already seen it can be represented as a rectangle. It can also be represented as a triangle. But you should remember here, while representing a triangle, the dots on the sides should be equal. You can see 1, 2, 3. Here also 1, 2, 3, and here also 1, 2, 3. The dots are equal. Here also 1, 2, 1, 2, and 1, 2. So number of dots should be equal to represent a triangle. So I hope this is clear to you. It's very easy. How can we represent the numbers using dots and thereby representing them as a figure, or you can say as an elementary shape. Now in your textbook, the shapes that are being given are a line, a square, a rectangle, and a triangle. No other shapes are given here. You cannot represent them in a circle or a semicircle or a cone or any other shapes, elementary shapes you can say, or a hexagon or something like that. According to your textbook, only these 4 patterns are given, So you can try out different numbers using this pattern. Clear? Now moving on. Patterns observation. Here what we'll be discussing is, the equation, you can say the how we simplify using the following the pattern. How can you simplify calculation? How can you simplify the operation that has been performed on two whole numbers or even more than that? How can we deal with that? We will be discussing here by the help of patterns. We have to observe the patterns. So let us see. Observation patterns can guide us in simplifying processes. Yes. In simplification, these patterns can help us for quick simplification, or else the calculation may be lengthy. So by observing the pattern, we can make our calculations or simplifications much more easier. So let us see. One example is given here, 117 plus 9. We know we can add this very easily, since it is a very small number. But what if it is a big number? So if we use the pattern, you can see here 117 plus 10 minus 1. It's the same thing. 10 minus 1 is 9. So why we have used here a number 10? Because whenever it is a multiple of 10, then as we have already in the earlier classes we have discussed something like this. Whenever it is a multiple of 10, our calculation becomes very easy, because we know what will be the result whenever we multiply or add or whatever operation we perform with the multiple of 10. It becomes very easy to calculate. Here it's 9. Say if it is 29 or something like that, we have to think a little. But whenever it is a multiple of 10, it directly comes in our mind. So here the calculation can be written as this. Similarly, what about minus? Here what we'll do is we'll subtract it by 10 and then add 1 to it. It's the same thing. 10 minus 10 plus 1, it is minus 9. So we got our answer. Similarly here also, what we have done is that we have written this 9 as 10 minus 1. Then what we have done is that we have used the distributive property of whole numbers. 84 into this minus, since minus is there, then 84 into 1. Got our answer? It's very easy. If we are going to do 84 into 9 by the normal method of multiplication, then it would have taken us a little bit of time. So by using this pattern, we can save time as well. Now next is this 99, the same thing, we've done it with 100. Always we are using a multiple of 10, you can see. This is the common thing in the patterns. Now next, 96 into 5. Okay, now 5 is there, what to do? We've again taken a multiple of 10. 5 can be written as 10 by 2, or 10 divided by 2 is 5. So it's the same thing. Then what we have done, we have multiplied 96 into 10, that is 960, divided by 2, 480. It's very easy. When you divide with 2, the division becomes very easy. Next, same thing, 15, 30 by 2. Now multiplying with 30 is very easy. Just have to multiply 32 into 3 and just add a 0 to it. That's 320. Then again, we get the answer. So that's it in today's video. And that brings us to the end of this chapter. Hope you'll have understood this chapter very well. Even if you don't understand something, any topics, you can go back to the earlier videos and you can check for yourself. So that's it for today. Thank you and have a nice day.